Okay, we're up to 2-3, day 2. Let's take a look at all these vocab words and try to apply it to this graph I've got made for you. So, we're going to go one piece at a time. So they're going to ask you, on a graph like this, or any graph, where is it increasing? The number one rule is, you got to remember, you got to picture yourself kind of on a roller coaster, and as you're moving left to right, where is it going up? So, if my roller coaster was here, I'm going left to right, I'm going down. But as soon as I get here, it turns and it goes up all the way from here, all the way to there, you're going up. So, what would my answer be? Well, I would say x is greater than or equal to -2, less than or equal to, this is 2, 2. So we're focusing on the x values all the way to 2. Now, mathematicians kind of argue about this, but the book is saying that this is the answer. So, it's kind of splitting hairs. I say that it starts here, so it includes -2, but your book is going to say you don't consider the beginning as it going up yet, because it just finished a downward cycle. But I'm not going to get too bent out of shape about that. I'm just not. So that's the only place where it's increasing, because if I kept going, it'd be decreasing. Okay, which is kind of leading to this. The rules left to right also apply. So now I'll get out my blue marker. Where is it decreasing? Well, as I move left to right on my roller coaster ride, where is it going? Down. Well, if this is my roller coaster right here, from here all the way to here, it's going down. So that's one section. So they would say x is less than -2. So from -2 that way, it's going down. Interval notation, it would be -infinity all the way to -2. But that's not the only place. So I'd get to here, then I'd go increasing, get to that point there, and it'd start going down again. So from 2 all the way to infinity, so they'd say, and x is greater than 2. Or and 2 all the way to infinity. Either way is fine. You should know how to use both of those notations. Well, let's keep going. Concave up. The definition is, as you move left to or right, you're going to go upwards in both directions. So if I pick out from here, and I go like this, I'm going up in both directions. So where does that happen? It happens from -infinity all the way to 2. And so they might say x is less than 2. That's a different way of saying that. So with that being said, concave down. Both directions, you're going to be going down. So I see that, okay, so this was concave up from here all the way to here. Get out a different colored marker, let's try purple. Concave down, both directions, well, look at it. If I went from here to here, so if I start here, my roller coaster ride, I go left, I'm going down. If I go right, I'm going down. So it starts here, and it goes that way. So from -2 to the right. So I'd say x is greater than -2. I would say or equals, but I'm not going to get bent out of shape about that. What's a local maximum? Well, it's kind of where the roller coaster ride peaks. Now this goes up and up and up forever, so you might say infinity, but they're talking about this space right here, the high point. So the local max would be right here, 2, 2. And the maximum value would be your y value. Local minimum is where it goes down and comes up. So where does that happen? Right here. So that'd be -2, -3, emphasizing this as your actual minimum value, because that's my y value. All right, a lot of new vocab, but I don't think it's outrageous. So the next thing they're going to throw at us are these questions. Is the graph or the equation a function or not a function? Now, I remember being taught this and being a little confused. It's like, you say f of x, g of x. These are all called functions. We say that 1,000 times, and all of a sudden, it's like, wait a minute, is this a function? Well, if I'm thinking, is it a graph, I'd say yes. Is this a function? And I think if it's a graph, I say yes, but there's some strict rules about a function. And basically what the word function by definition means, for every unique x, there's a unique y. Now I plugged a few of these in, like -3 for x would be -6 plus 1 is -5, and I just did that for all these values. Notice there are no repeating y values. So I say yes, it's a function. Now there's a faster way than doing this, and you just go a vertical line test and you say, hey, it only hit it in one spot. It's a function. Now if we apply that to this vertical line test, we see that there's two spots where we're like, nope, it's not a function. Well, let's dive a little deeper. I put -4 in for x, square it, I get 16. If I subtract 16 from both sides, I get y squared equals 0. Take the square root, I get 0. Now let's just for kicks and giggles, -1 in for x. So that'd be 1. Subtract it, I get y squared equals 15. Take the square root of both sides, and I get the square root of 15. And all of these values will just happen. So for example, if I go -1, supposed to go up the square root of 15, which would be like 4.9. So you can see that it's true, but look, we've got a matching square root of 15 there and a matching square root of 15 here. So if I square a -1 here, I get a +1. If I square a 1 here, I get a +1. So both for the -1 and the 1, I get the same y. Notice, same y, same y. So this is no, it's not a function. Again, vertical line test is the key to this, but there's more to it. I just wanted you to see it, okay? So remember, yes, this is a graph, but by definition, it is not a function. Vertical line test. Pretty simple. Okay, so what they're going to throw at us now is, how do we restrict or limit the range or domains to make a certain graph qualify as a function? So as I just said to you, if we take vertical line test, this thing fails. So it's like, nope. So what if we restricted the range, watch this now, and we said, hey, y is greater than or equal to 0, less than or equal to 4. See, that's 0, 4. So we're going from 0 to 4. Now does it pass the vertical line test? Yes. So we restricted the range. Now what if we restricted the range differently, and instead of doing that, we restrict the range from 0, actually -4, all the way up to 0. So forget I said that. This is restricting the range from 0 to -4, and it still passes. So this portion of the actual graph passes, so that would be a function. Now what if we restrict the domain? We're like, okay, let's check this out. And we restrict the domain, which is our x, and we say, all right, x greater than or equal to -4, because this is -4, all the way to 0. Does this portion pass the test? No. So what if we restricted it to this side and said, hey, let's forget about this side. Let's restrict it from 0 all the way to 4. See, this is my 4, this is my 0. What about this portion of this graph? Well, again, it fails. So by restricting the domain, it doesn't help us, but by restricting the range, it does help us. Okay. Couple more things and we'll be done with this video. Okay, so another concept is figuring out the signs of a circle. Now, it means if I spin the spinner that far, which is 3 times 180 over 7, which is going to require me to grab my calculator here a second. So I got 540 divided by 7. I'm spinning my spinner 77.1 degrees. That means I'm in the first quadrant. So So if I go up somewhere in here, 77.1 degrees, all my signs are positive. So sine would be positive, cosine would be positive, tangent would be positive. So all of this, here's my x value, here's my y value, that's going to be a positive, positive. All right, what about this? Well, that one, I'd have to go negative 17, so 17 times 180, because that's what pi is, 3,060. So I get negative 3,060. As you can see, we're going to have to do some quick math here. I'm just going to go 360 times 9, and I'm going to go 360, because that was too much, times 8, 2880. So I'm going to say, all right, I know I'm going down, so I have to go around 360, around 360. 8 times in a negative direction would be negative. Actually, I'm going to add, I'm going to take that negative off. I don't want to confuse you, but 2880. So I get 0, and I get 8, and I get 1. So that's a negative. So I went around 360 8 times, but then I have to keep going another 180. So I stopped right here. Now notice, that's one of our quadrantals. So I'd have to stop somewhere near it to really let my brain focus. That right there is negative, and so my x value would be negative, and then my y value would be 0, and so 0 is neither positive or negative. So it's just kind of helping you spin your spinner, think about your quadrants, and what the values of each side is. So that's a nice little exercise for you to practice. All right. Okay, the last portion of this video I think is pretty simple. So remember guys, I don't know if we've even said this yet, but an even function is symmetric around the y-axis. An odd is symmetric about the origin. So again, I'm not going to go into too much detail just to take up all your videos. This doesn't ask you to graph it, although if you did, these rules would apply here if you're right. So if we went to decimals and looked at this, is it even or odd? Well, the big hint is right here. Look at all those powers. Those are even. So this is an even function. Pretty simple. 5, 3, 1. That's an odd. Now a little curveball they throw at you is this. Well, that's the same thing as 8x to the 5th power. So if I brought that up, it would just be another one of these. So I have 5 3's. So this is also odd. Again, if you put this in decimals, you would follow these rules, but I don't even know if we've talked about that yet. So right now they're just looking for the degree. Throw this out there. If it was 8x to the 6th plus 5x cubed, notice I have an odd and an even. This would be neither. So keep that in mind as well. That finishes our lesson right there. So good luck on your homework.